So when we're trying to evaluate the change in resistance of our strain gauge, the typical way that this is done is by using a Wheatstone bridge. So a Wheatstone bridge is used to measure the change in resistance. Can be used to measure the change of resistance of our gauge. So we did a little bit of this during earlier in a few earlier classes. So this should be a little bit of a review. All right, but if we have, we can say that the change in the output voltage can be proportional to the input voltage and the resistances of our within our Wheatstone bridge. Okay, so if we can simplify this equation down a little bit, if we say that all the resistances are initially the same, all right, and we can say that there was no voltage across our circuit initially. Okay, so if we do all that, what we can say is that this relationship here, we can simplify it down to this equation here. Okay, now in most cases, the change in resistance compared to the original resistance is going to be very, 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 very small. All right, so we can basically set this term on the denominator equal to 0, and this equation simplifies down even more. Okay, so if we substitute in the relationship we had earlier, defined earlier for the gauge factor and the change in resistance, all right, our change in our output voltage over our excitation voltage, we can simplify it to be a function of the gauge factor instead of the change of resistance. Okay, so if we plug in all these values in, again, we assume that the change in resistance, all right, over the resistance is approximately equal to 0. All right, we can simplify it down further to eliminate all the delta R over R terms. Okay, so now we have a direct relationship between the change in the output voltage and our strain. All right, so the one thing in order to make this approximation work or to help with our approximation is a lot of times we'll use something called a shunt resistor, which is just an adjustable resistor that's used within the Wheatstone bridge. All right, and the whole point of this shunt resistor is to get the output voltage across our Wheatstone bridge when there's no strain being applied to the system or to your resistor to your Wheatstone bridge. The whole goal is to get the initially to have the output voltage to be equal to 0 in both of these cases. Okay, so all right, so there's a in both these cases we're just interested in getting that output voltage to be equal to 0. All right, so we'll do an example problem to show how you can use these relationships to determine the strain within the strain within a strain gauge in a Wheatstone bridge.